Determine the number of Hamilton circuits in a graph. So let's first talk about what this means. A Hamilton circuit is a circuit that includes every vertex exactly once. And remember that a circuit means we start and end at the same vertex. A complete graph is a graph where every vertex is connected to every other vertex. Okay. To find the number of possible Hamilton circuits for n vertices in a complete graph, there will be basically n minus 1 factorial. Now, n minus 1 basically means we're going to take however many vertices there are and plug that in. Factorial, if I would have 8 factorial, that's like saying we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is what this right here shows. Okay, so factorial, for some calculators, there is a button for that. But the thing is about these pieces, let me get my button back here. If I would say that I have 3 points here, whether I would go this way or start over here and go this way, it's the same thing. So to find out the number of unique circuits, because we can go forward and then backwards, we take that n minus 1 factorial and we divide by 2. So that takes care of the forward and backward piece, and then we have the number of unique circuits. So let's do some examples. How many circuits would a complete graph with 12 vertices have? Okay, so that would make n equal to 12 because there are 12 vertices. So I would take 12 minus 1 factorial. 12 minus 1 we know to be 11. And I would take 11 factorial. Now, if you have a factorial button on your calculator, great, hit the button. If not, you would take 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And you would get an answer of 39,916,800 possible Hamilton circuits. That's a lot. Now, unique, if you want the number of unique circuits, we would divide by 2 and end up with 19,958,400 unique circuits. Whew, that's a lot. 12 vertices is a lot, right? Every one of them is connected to 11 different, that's a lot of lines. Okay, now let's look at this complete graph. How many unique Hamilton circuits does the following graph have? So you can see here that every point is connected to every other point, right? For every vertex, excuse me. So how many vertices do we have? 1, 2, 3, 4, 5. So n equals 5. So when I plug this in, I would say 5 minus 1 factorial. So 4 factorial, again, that means 4 times 3 times 2 times 1. And we know there are 24 circuits. But to be unique, we would divide that by 2, and we would end up with 12 unique Hamilton circuits for this particular graph.